Let us compare the powder XRD analysis of amorphous material with nanocrystalline material. We know that if any dimension of a material is in the range of from 1 to 100 nanometer, that we call nanocrystalline materials, right? This is very interesting topic because we know that the amorphous material give the broad peak. Similarly, the nanomaterial also gives the broad peak. So how you will know that our material is basically amorphous, or there is some impurities, or whether it is nanocrystalline material, right? We know that the amorphous material do not produce visible or sharp peaks because, as I explained many times, that amorphous material is something like the broken mirror. The broken mirror. So when you shine light on a broken mirror, it will give you diffuse reflection. It will not give you any intensity. So this means that this is the diffuse here, amorphous gives. Similarly, if the size is less than 5 nanometer, or if the size is less than 2 nanometer, so the XRD pattern also gives the broad peaks similar to the amorphous material. So there is a huge discrepancy here. Look these two sentences, very interesting, right? If the XRD pattern contains impurity or amorphous component in addition to the nanocrystalline component. For example, if we have a material here, for example, this is nano here, and this is here amorphous here. There is a disorder of a material, and here is again nano, and here is again nano. But so how you will know that the XRD gives you broad peak, and this peak is from nano or from impurity? For example, okay, this is one case. Let's compare this with only nanomaterial. This is completely crystalline nanomaterial. Completely crystalline nanomaterial. It also gives the same pattern. And here is the impurity or amorphous nature in the material. So how you will differentiate that my material there is no impurity. My material is a pure crystalline material, because in both cases you get the same XRD pattern. So this means that there is a problem, and we just need additional characterization techniques to reveal whether the sample is free from impurities or there is no amorphous impurities in the sample. And this is what I told, that we need to have STEM analysis and also high resolution TEM analysis. This is such a great comparison here. If you are not sure that how the small particles gives me broad peak, this is as I explained in my past video as well, that if we decrease the size, so this peak you see, it's getting broader and broader. And this is the same like amorphous also. The amorphous material also gives you the broad peak. I give the example of a mirror, but broken mirror. If you shine light on broken mirror, so it will give you diffuse light like this. You see here?